So this paper discusses the hardware architecture of parallel computers, I said. It defines the classifications of computers and the type of parallel computers. Now we are viewing the first unit. In the first unit, we are discussing the fundamentals of parallel computers. So far we have seen the parallel computing model. Even we are discussing the first topic on your unit 1. So we have seen parallel computing model. Under that parallel computing model, I define what parallelism is and in which form it exists, and some more concepts, fundamental concepts of parallelism. Then in the last session, I said the elements of modern computer. There we discussed, under the elements of modern computer, there we discussed computing problems, algorithms and data structures. Okay. Even I displayed a diagram of elements of modern computers. So here this diagram explains three things. The concepts shown in boxes are the real world entities, and the things that are within the circles are the components of computers. And the arrows, 3 arrows are there, and the 3 arrows are connecting the real world quantities represented in boxes to the things to the computer components, things within the computer components, computer system. Okay, so with that we define different types of computing models, that means computing problems. I said numerical problems and alphanumerical problems and artificial intelligence. So finally I concluded with 3 types of computing models: numerical computing used in science and technology, transaction processing, that means alphanumerical problems used in business and governmental areas. Mainly the transaction processing is doing database process. And the third one, logical reasoning, that means artificial intelligence, which is doing logical inferences and symbolic manipulation process, or the combination of either of the 3. So these are all the types of computing models I said. Then next we define what are algorithms and data structures. First of all, algorithms are the step-by-step defining a process and that are written before the program writing process, I said. Algorithm is a manual process which defines the entire process, given process, as a step-by-step basis, I said. Then the data structures. Data structures are ordering the data, representing the data in an order within a computer, I said. So in the field of computer science or computing, some special algorithms and data structures are needed for each problem that we define. Each computing problem that we define, I said. For example, numerical algorithms are deterministic. They are using deterministic algorithm and structured data, I said. Then AI uses non-deterministic algorithms. So these concepts, the algorithmic and data structure concepts, are valid for both sequential and parallel processing, I said. So finally I said parallel processing needs interdisciplinary communication among the peoples, theoreticians, experimentalists and programmers. That means it needs a proper communication in between the users and the programmers. So based on that communication, people have to arrange the parallel computing model, I said. So with this point I concluded the last session. So next we have to go for the third component of, that means third element of, which one? Elements of modern computer. So before going to discuss that, I would like to show the diagram once again. You see that? So we completed computing problems, algorithms and data structures. Next we have to discuss the hardware resources, that means parts belonging to the circle. So I already told you there are three types of components within this diagram. One is the real world quantities, another one is the computing components, computer components, and the third one is the arrows representing the links between the real world components and the computer components, I said. So after computing problems and algorithms data structure, next we have to discuss the hardware resources, that means hardware components that are available on the computer side. Mainly here there are three hardware components: operating systems, hardware architectures and application software. You see the diagram that are represented within this circle. Application software are on the outermost circle, then following that operating system is there, the innermost circle is the hardware architecture. So what is the meaning? The application software are used for communicating with the real world. They are getting commands from the real world and give it to operating system. The operating system converts the commands into hardware signal, and finally the OS gives to where? Hardware architecture. The hardware architecture executes the program. Okay. So now we have to take the hardware architecture of modern computer. Okay. That means hardware resources. So as I already told you, the hardware resources are indicated by using three circles. So the main component of hardware resource is, what is that? Operating system. The next one is application software, and the innermost one, hardware resources. So what are all the hardware resources? Standard hardware resources exist within a computer: CPU, central processing unit, input output, that means IO, and the memory. Okay, so these are all forming the hardware resources. In addition to that, some special devices like scanners, optical readers, cameras, printers, that are also included as the hardware resources. So these are all valid for a single computer, single sequential or parallel computer. So once again I would like to remind one point. The concepts that we are discussing up to this topic are valid for both sequential and parallel computers. Suppose there is a sequential computer, single sequential computer or single parallel computer. The hardware resources are like this. Suppose you take a network of computers, either on both sides, sequential or parallel. Suppose you take the computer network on sequential computer side. Suppose you take the network on sequential computer. So as a network, it may contain terminals, workstations. So in case of network, terminals and workstations are also included within the hardware resource side. Then importantly, some software interfaces are needed. Application software is there, operating system is there, they are also software. Along with that, a special kind of software. What is that? Software interfaces are needed. So what are software interfaces? Software interfaces are converting the logic, statements, data into hardware signal. The main duty of a software interface is to convert the logic or data into hardware signal. So what are all the software interfaces? For example, compilers, used for converting high-level language program into machine code, that means object code. Then driver software, used for activating a device, connected device with a computer. So these are all the software interfaces. So these concepts that we discussed are enabling the users and user programs to run on different architecture. Even the architecture will vary. Even every computer is having different kind of processor and memory. The concepts that we discussed: operating system, application software, hardware resources, and software interfaces. These are all making the user's programs to run on different architecture. Okay. Next, we have to take the operating system in detail. So what an OS is? We know well, operating system is a software which is used for controlling the entire computer process. OS is controlling each device on a computer. Even an effective OS operating system has to handle efficient allocation and deallocation of resources like memory, processor. Okay, OS has to handle efficient allocation deallocation process. Then only it's possible for a computer to do the work within a shorter period of time. So that is on the hands of OS. Moreover, an operating system has to support techniques like multiprocessing, multi-threading, and virtual memory. In order to boost up the process, faster the process with the limited hardware resources that we have seen, a OS has to also use this technique, simulate these techniques: multiprocessing, multitasking, and virtual memory. Okay. Along with operating system, lot of application software are used for satisfying the user needs. So what are application software? Programs that we are using, that means languages that we are using to do programs: Java, .NET. So these are all some application software, PHP. So these are all also needed in order to suit the user need. Suppose there is a computer and operating system, that would not enough to satisfy the user need. A user need a specific problem to be solved on a computer. That user cannot do that only with the OS and the computer. So for that one has to write a program. So for that programming process, an application software language is needed. Okay. One kind of program is the benchmarking. So what a benchmarking is? It's a program, and that program is used for assessing, qualifying the quality of a computer, quality of OS, and quality of application software. So they are fixing the performance. So this one is better, this OS is doing this much percentage. The application programming software, the language is doing these quantities, these concepts. Okay, so like that. Another one, the important concept that we have to discuss is mapping, a process carried out by the OS operating system. Even it is expected as a 2-mark question in case if you are facing the normal examination, written examination. Otherwise, suppose you are going to do an online examination, there it may be asked as a choice. That means multiple choice questions. So what a mapping is? It's a bidirectional process that converts algorithmic steps into hardware signals and the hardware signals into algorithmic steps, that means logic. Very simple. Bidirectional process converts the real world data into hardware signal and the hardware signal into real world data. So here I would like to show the mapping process where it exists. So we have to go back for the diagram. So there you can see where mapping exists. See there, the mapping exists in between algorithm and data structures and the hardware resources. So as a mapping process which converts the real world data into hardware signal and actually they are sending the real world data from the user side to the computer, and the hardware signals into real world data, getting the data from computer, that means getting the result from the computer, and shows that, converts the data into signal data into real world data and shows to users. So it's a mapping process, and operating system has to do this mapping well. Okay. So it's a important 2-mark question. Bidirectional process converts algorithmic steps into hardware signals and vice versa. So the mapping also involves, during the mapping process has to involve process scheduling, memory optimization, and sizing of memory, and inter-process communication. So these are all the complexities that a mapping process has to face during the mapping process. The OS has to resolve all the practical difficulties like this process scheduling, memory optimization, and memory size, and inter-process communication. It has to resolve these complexities. Okay. Then we have to go for where? One more topic, that means software or system software support. So what a software or system software support is? On the diagram we have shown, even we came to know there are two software components exist on the hardware side of the computer, on the circle. One is the application software, another one is the operating system. Application software is used for doing program, and the OS is used for controlling the entire computer, and converts the user signals into machine signals. Okay. So along with that, some more software support is needed. Some more software, system software, or exist as elements of the modern computer. Okay, so such a system software support is needed. A healthy system software support is needed for the effective operation. So what are all that software? What are all that system software we have to see? So what is the need of that? Users are writing the programs by using high-level languages. They cannot know the computer language, that is 0 and 1. And the computer cannot know the user's language. So in between that, user programs and the computer process, a translation is needed, a concept is needed. So for that purposes, for the conversion process, system software are needed. Okay. So a program in high level language is translated into object code. So who is doing that? By using an optimized compiler. So as a compiler which converts high level language into object code. Then one more system software, assembler, translates that converted object code into machine code. That's all. So both compiler and assembler are just converting the code. So another tool, system software is needed to invoke the running process of that converted program. So what is that? Loader. So loader initiates the program execution through the OS kernel. You know kernel, it exists in the innermost of the OS, a low level routine which bridges the hardware resources and the software, or indirectly real world. So these are all also asked as a questions. What is compiler, assembler, loader? So these are all asked in the usual examination, written examination, under the 2 marks. Suppose you are facing, once again I am saying, suppose you are facing online examination, these are all asked as the objective type questions. Okay. So whatever it is, compiler, assembler, or loader, even it's a main challenge for the loader to effectively bind the needed resources for a program. Suppose a program is started to run, it needs some resources like memory, printer, like that, or a file. So the loader has to properly initiate and bind the needed resources with that program. It's a major fight. It's a major challenge also, because another program may also require. So it's the duty of the loader program to effectively bind the needed resources. That's why I said resource binding is the major fact. So what is needed here? So here a major concept is needed. What is that? Each system program has to effectively allocate the hardware resources. That would increases the programming efficiency or programmability of a computer. Okay. We are going to wind up the today's session. We have to also see a little topic, parallel programming support. So I already told you the concepts that we are discussing are valid for both the sequential and the parallel computers. Even we are discussing with that point, maximum the available hardware and software is supporting sequential process. There is no full supportment of hardware and software for parallel programming process. So a parallel programming support is needed. As per the today trend, even we initiated the parallel processing concept, even we are talking about the parallel processing, practically a parallel programming support is needed on both hardware and software side. So the main problem is, what is that? The maximum software support is based on sequential computers. The language that are available are only supporting sequential programming. Okay, no language is fully supporting parallel programming process. So newer languages are needed. Newer language supporting is needed for parallel computers, parallel processing. So with the availability of hardware and software, it is very difficult to attain parallelism. So attaining parallelism is very difficult task today. Hardware independent parallelism and portability among different machines are also a major question. So without depending on hardware, how to attain the parallelism is a major question today. Most of the software processes, parallel software processes, are converting sequential programs into parallel process, and that converted parallel program is running on the parallel computers. So there is no direct parallel program today. So only implicit, that means converting a sequential program and attaining the parallelism on a parallel computer. Later we are going to see that implicit and explicit parallelism, types of parallelism. So what about implicit parallelism? Converting a sequential process into parallel. That's I said that just now. That's I said now. Converting sequential program into parallel process. So that is implicit parallelism. So attaining implicit parallelism is possible today. There is no chance for attaining explicit parallelism. That means implement direct hardware, writing direct parallel program is not possible today. So attempting to explicit parallelism directly is the main need of today computing process.